Hello students, I am going to explain about raindrop problem in relation to work and energy theorem. In relation to work energy theorem, I already pointed that main use of work energy theorem is to come to know about parameters of moving bodies, say velocity, acceleration, distance covered, etc. of the moving body under the action of variable forces. See that I already pointed that main use of work energy theorem is to come to know about parameters of moving bodies, say velocity, acceleration, distance covered, etc. under the action of variable forces. This is what the main task of work energy theorem. Actually, the simple formulas, say V is equal to U plus AT, S is equal to UT plus half AT square, are useful only when the acceleration is constant or force is constant, because force F is equal to m into A. So if A is constant, force is constant. So these formulas, all these formulas, S is equal to UT plus AT square, V is equal to U plus AT, are valid only when the acceleration or force are constant. But when force is variable force, okay, variable force. See, the simple formulas, say V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to 2AS, are valid only when acceleration is constant. See that acceleration is constant means force F is equal to ma is constant. S is equal to UT plus are valid only when the force is constant. That is what. Next, for example, if we see the case of variable force, say variable acceleration, the simple formulas are not valid. V is equal to U plus AT, S equal to UT plus half AT square, V square minus U square is equal to AS are not valid when the acceleration is not constant, if it is a variable. Actually, V is equal to dx plus dt or x is equal to integral of V dt. Such formulas are to be used when acceleration is not constant. Remember that V is equal to dx by dt, x is equal to integral of V dt are valid whether the acceleration is constant or not. See that these formulas are valid even when the acceleration is constant or even when the acceleration is variable, or under the variable force or constant force, these formulas are valid. Also remember that to use the formula V is equal to dx by dt, we need mathematical expression for x. See that even if you use the differential formula V is equal to dx by dt to find velocity for the given displacement, the displacement is denoted here x. The x should have mathematical expression like clearly x is equal to mt kt square plus sin t. Then you can differentiate this function or differentiate displacement function with respect to time. Then only we find velocity v by using V is equal to dx by dt. Similarly, we should know about mathematical expression for V, say V is equal to m sin t, m by q into t square, etc. Like so, to find displacement x using x is equal to integral of V dt. Suppose if you want to use x is equal to integral of V dt, you should have a mathematical expression for velocity like V is equal to m sin t plus m by q into t square. M and q are constant but time is variable. See, the velocity should be a function of time, and several mathematical functions will enter. Such expressions you need to evaluate x is equal to integral of V dt. Similarly, to use V is equal to dx by dt, you should know the expression of mathematical expression for x is equal to m into t plus kt square plus n into t. See that mathematical expressions for displacement and velocity will be known only when the motion of the particle is clearly explained, but that is not possible in nature. In nature, it is not possible to get exact expressions for displacement, exact expressions for velocity. So even though V is equal to dx by dt, x is equal to integral of V dt are valid whether the acceleration is constant or variable, but the difficulty is to use these formulas, you need the expressions, mathematical expressions for displacement and mathematical expressions for velocity. And so there are limitations for the formulas. V is equal to U plus AT, S equal to UT plus half AT square, V square minus U square is equal to AS. You need constant acceleration. But for the formulas V is equal to dx by dt, x is equal to the integral of V dt are valid for constant or variable acceleration, but you need mathematical expressions for x and v. These are the limitations of these formulas. So under these conditions, suppose if there are no mathematical expressions for force, acceleration, displacement and velocity. Then how can you find the displacement, velocity of a moving particle? Here at this case came to our help the work energy theorem. And here I am going to explain raindrop problem to understand how the work energy theorem is going to helpful even though you don't know expression for force, but work energy theorem will help us to find the other parameters of moving body even under the action of variable force for which there is no mathematical expression. See that here a raindrop is falling, and there is a downward gravitational force Fg is acting and a gravitational force Fg is acting, and there is upward air resistance force FAR is acting on the raindrop. Okay, this is the case. But we know the expression for Fg among the two forces acting on the raindrop. We know expression for Fg to be m into g, but we don't know expression for F air resistance formula. We don't know any expression about air, but one information that F air is proportional to speed of the drop, but no clear mathematical expression for F air. See, one thing we know it about the F air is proportional to velocity, but we don't have any mathematical expression for F air, and there is no clear mathematical expression, only the information that F air is proportional to velocity of the raindrop. That is only that, but we know very precise mathematical expression, exact mathematical expression for Fg is equal to m into g. And now let us come to this one. And here a raindrop is falling from clouds to ground. From the clouds it is starting with initial velocity, and while reaching the ground, just before touching the ground, the velocity of the raindrop to be 50 meters per second. The distance from clouds to earth is about 1000 meters or 1 kilometers. This is the problem. Okay, here you want to find air velocity, air force. What is the air resistance force? Okay, that is the situation. That information is, anyway, initial velocity is 0, means initial kinetic energy is 0 of mu square is 0. Final velocity is 50 meter per second, means final kinetic energy of mv square. Therefore, change in kinetic energy is equal to final kinetic energy minus initial kinetic energy. Change in kinetic energy is equal to final kinetic energy minus initial kinetic energy. Final kinetic energy of mv square, initial kinetic energy of mu square. U is 0. Therefore, you are going to get of mv square as the final expression for change in kinetic energy. That is all equal to 1 by 2 m into v square. V is 50. But what about mass? Mass of the raindrop is 1 gram. 1 gram is equal to 1 by 1000 kgs. 1 by 1000 kgs. Therefore, in place of m, I have substituted 1 by 1000. And so the delta change in kinetic energy is to be 1.25 joules. You know that the unit of energy is joules. Okay. Now you consider the raindrop is falling from the clouds, and downward force is gravitational force, upward force is air frictional force, air resistance force, and the displacement is 1000 meters. Here raindrop is covering 1000 meters under the action of Fg and Fa. So here work is done by two forces. So the raindrop is making displacement of 1000 meters under the action of two forces. So here work is done by two forces. One is Fg and another one is Fa. Let us see that. One by Fg and Fa. See that Fg and displacement are in the same direction. See that in the figure, Fg is downward and displacement is also downward. So Fg and D are in the same direction. Therefore, same direction vectors have zero angle between them. So work done by Fg is equal to Fg bar dot D bar is equal to Fg D cos 0, because angle is 0 between parallel vectors. So cos 0 is 1. So the final result is Fg into D. Fg is equal to m into g into 1000. M is equal to 1 by 1000 kgs, because mass of the raindrop is 1 gram. 1 gram is equal to 1 by 1000. G is equal to, I have taken 9.8 to be approximate to be 10, and D is 1000. So after all the calculations, you are going to get work done by Fg. Work done by Fg is equal to 10 joules. Work done by F air. See that figure. In the figure, work done by air resistance force is acting upward. Whereas displacement is downward. So opposite vectors, F air and displacement are in opposite direction. So the angle between them is 180 degrees. 180 degrees. So the work done by F air is equal to F air dot d bar is equal to F air d cos 180. Cos 180 is minus 1. F air into 1000. D means 1000 minus 1. W work done by air. Work done by air is WAR. WAR is equal to minus F air into 1000. Minus F air into 1000. Okay. Hi Baba. The total work done on raindrop by F air and Fg. Total work done on raindrop by F air and Fg is total work done is equal to total work done by Fg plus work done by F air. Work done by Fg is already found to be 10. Work done by F air is found to be minus FAR into 1000. Just see that. Work done by F air. Work done by F air ఎలా ఉందంటే work done by F air is equal to F air dot d bar is equal to F air d into cos 180. Cos 180 is minus 1. So work done by F air is equal to minus F air into 1000. But work done by Fg is 10 joules because the values are substituted correctly. But here we don't know the value of F air. Okay, that is what we are going to find in this problem. So total work done is equal to work done by Fg plus work done by air. Work done by Fg is 10. Work done by F air is equal to minus F air into 1000 is equal to total work done. But according to work energy theorem, total work done is equal to change in kinetic energy. Total work done is equal to change in kinetic energy. W2 is equal to delta K. Delta K is already found. Delta K is already found. See that here we determined it. Delta K. Here we consider a situation where raindrop is starting with the initial velocity of 0 and reaching the ground with a velocity of 50 meters per second. So change in kinetic energy is final kinetic energy minus initial kinetic energy. That we have calculated here to be 1.25 joules. So that value here we are substituting. That is total work done is equal to change in kinetic energy. But total work done is equal to work done by Fg and work done by air. So that is equal to 10 minus. So we are simply substituting in place of Ft delta Ke. And so the above expression, this expression is going to become 10 minus FAR 1000 is equal to delta K. Delta K is equal to 1.25. And only unknown thing is in this expression is F air. And after transferring 10 right hand side, you are getting minus 10. 1.25 minus 10 is going to become minus 8.75. So F air is equal to minus 8.75 minus FAR is equal to minus 8.7 divided by 1000. 1000. So finally, if you have this minus will be cancelled. So F air, and F air means air frictional force or air resistance force is equal to 0.00875 newtons. Actually, this air frictional force F air is average frictional force. It is not correct value. It is only average frictional force. Anyway, by work energy theorem, we are able to find at least average value of complex variable air frictional force. This knowledge about average value of frictional force helps us to get variation of frictional force with the time by conducting further test. Okay, if you conduct elaborate test and experiments, there you will get some rough approximate graph of air resistance. And already you know average value from the work energy theorem to be 0.00875 newtons. So to that approximate curve you can test whether the average value is 0.00875 newtons or not. Okay, this is all about raindrop problem. I continue with the next video. Thank you.